In this video, I'm going to talk about the different types of hydrocarbons and also how to name some hydrocarbons. So hydrocarbons are just exactly what the name suggests. They're composed of molecules that only contain carbon and hydrogen, and that's why they're called hydrocarbons. Now, a major group of hydrocarbons are what we call aliphatic hydrocarbons. Aliphatic hydrocarbons are basically straight chain hydrocarbons, and these straight chains, remember, hydrocarbons are only carbon and hydrogens, so it's basically a repetition of carbon hydrogen bonds, and it makes a straight chain. Now, aliphatic hydrocarbons don't have to just be straight chains. We could have branches coming off of them. So for example, we can have a 3-carbon chain, or let's say a 5-carbon chain, and then we could put some other carbon as a branch off of that. And if we put hydrogens all around this, this would be an aliphatic hydrocarbon that has branches on it. And in this case, it has a branch on the 3rd carbon. And remember, every carbon has to have 4 bonds. Now, the way we would simplify this, using the line diagram to represent the each of the carbons, where each of the points, we have 5 here, so we would write 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 carbons. And then in the middle carbon, we have a 2 carbon. So we would put 2 points to represent those 2 carbons. And so this is the line diagram for this molecule right here. This is a aliphatic hydrocarbon that has a branch on it. So it could be a straight chain, or it can have branches. And then also aliphatic hydrocarbons can also be cyclical in nature. So in a previous video, I showed you cyclic 6-carbon ring, 1, 2, 3, 4, 5, 6 carbons, and that makes a ring. Now there are 3 types of, or I should say 3 groups, that we can combine all these hydrocarbons in that involve these straight chains. The first group, and the simplest of these, are what we call alkanes. Alkanes is simply that all the carbon-carbon bonds are all single bonds. So we only have single carbon-carbon bonds in an alkane. The second type of group is what we call an alkene. In an alkene, we have at least 1 carbon-carbon double bond. And the third group is what we call an alkyne, which has at least 1 carbon-carbon triple bond. So 3 major groups for hydrocarbons include alkanes, which are only carbon-carbon single bonds, alkenes, which has at least 1 double bond between 2 carbon atoms, or an alkyne, which has at least a triple bond, at least 1 triple bond between carbon atoms. There is a 4th group, and I'm going to go into more details about it in a little bit, but the 4th group are what we call aromatic. And that is also a type of hydrocarbon as well, and I'll go into more detail about that in a minute. Before I do that, I want to go over how to name hydrocarbons. Just like in inorganic chemistry and naming the metals and the nonmetals that are combined together, we have naming conventions for organic compounds as well. And so the naming convention is governed by an organization called the International Union of Pure and Applied Chemistry, or IUPAC as short. And this is the organization that gives all the rules for naming compounds. So how do we name hydrocarbons? Well, there's 2 groups, there's 2 parts to a name. You have your prefixes and you have your suffixes. And so let's first talk about the suffixes, or the ending of the name. The ending of a name on an organic compound basically distinguishes the type of functional group that that molecule belongs in. So we've already kind of went over three functional groups of aliphatic hydrocarbons, the alkanes, alkenes, and alkynes, based on if it's all single bonds, double bonds, or triple bonds. So if we think about the alkane, we notice that alkane ends in the prefix ane. And so all alkanes also end in that prefix. Alkenes end with the suffix of ene, and so the names of all alkenes also have that ene suffix or ending. And then the last one, alkynes, which are triple bonds, have the suffix yne, and so all alkynes will also have that ending as well. Now, what about the prefixes? So the suffix tells us what type of hydrocarbon it is. The prefixes tell us how many carbons are in that particular hydrocarbon. And so we have prefixes to designate each number of carbons. So if we can make a table here for number of carbons and then what the prefix would be. If we have one carbon, the prefix would be meth. And so a one carbon alkane would be methane. If we had two carbons, the prefix is ATH or eth. 3 carbons is prop, 4 is BUT, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. And so if you have a 4 carbon chain that's all single bonds, we would call that a butane molecule. So if I drew a butane molecule, which is 4 carbons, it would look like that. This would be butane. It is only single bonds, and we have 1, 2, 3, 4 carbons, which correspond to the prefix but. If we have an 8 carbon chain, 1, 2, 3, 4, 5, 6, 7, 8, this name would be octane. Now if we have the double bond, we would add the suffix "ene." We would replace this A for an E for an "ene." So for example, propene would be pro has 3 carbons, so 1, 2, 3, and then we have the "ene" to represent a double bond, so we would put a double bond between the 2 carbons. Now if you go on in chemistry, you will learn that we eventually put numbers in front to represent where these double bonds are and where we can put other things along these chains. So that is the simplest type of compound to name: alkanes, alkenes, and alkynes. Is all based off of these numbers and these prefixes, with the endings being ane, ene, or ine, depending on what type of aliphatic hydrocarbon it is. Now that last type of hydrocarbon I want to talk about are the aromatic hydrocarbons. So the simplest aromatic hydrocarbon is a compound called benzene. Benzene is a 6-membered ring, and all aromatic hydrocarbons have a 6-membered ring with alternating double single bonds. So here's our 6-membered ring, and then we're going to alternate the double and single bond. So we have a double, single, double, single, double, single bond for each one of the carbon-carbon bonds. This is the simplest aromatic compound, which is benzene. So any compound that has this ring with a 6-membered ring and alternating double bonds is an aromatic compound. Now you might look at this and say, well, is there a difference if we put the double bond between this carbon, these 3 carbons, rather than these carbons? So we could also draw this like this. These two molecules actually are the same molecule. This is what we call a resonance form. And so what ends up happening is with benzene, which is a six-membered ring, we have alternating double single bonds, and both of these molecules are actually present at the same time. And so a lot of times we represent that with a double arrow, showing that both of these molecules are being represented. It's very difficult on paper to show what the true function or the true structure of the benzene molecule is. So this is why we have a resonance form. This molecule itself does not exist. This one does not exist. What exists is a combination of these two molecules all at the same time. And so this is what we call resonance forms for the benzene molecule. Now, aromatic compounds like benzene can have other things grouped on there. So we could easily put something on one of these rings. Let's say we want to put OH for an alcohol. And so this would be another type of aromatic compound, which would also have an OH group to it. We could put another straight chain substituted onto it. So let's say we put a 1, 2, 3 carbon chain on top and maybe bromine right there. So we can have lots and lots of different types of aromatic compounds.